Hi, my name is Tony from Typhoon Hill. In this video, I will demonstrate how you can monitor the behavior of your controller using Typhoon Hill Capture and Scope. To do this, I will use Typhoon Hill 600 TI-F2808 controller with grid-connected converter control algorithm, which is connected to our Hill with TI DSP interface board. Here is the power stage schematic of the grid-connected inverter our Hill will emulate, which is easily drawn with our schematic editor. After compiling, model is ready to be loaded into the control panel for the emulation. Before we begin the emulation, we need to set the sources and emulation parameters. Emulation settings can also be saved and loaded, so you don't have to do it manually every time you need to change the model. Or you can just load the predefined settings. We can now start the simulation. Let's add some grid voltages, set the trigger parameters, and increase the time base. We need to observe the currents also. Okay, to do this, we will add more viewports and assign the currents to them. We can see that we don't have any current signals. This is because our controller is still not running. So let's start now the controller. We would also like to observe the digital PWM signals and how they affect on currents. To do this, first we will enable capturing the digital signals. As you can see, the PWM signals are fast, so let's decrease the time base. You have probably noticed that the signal scaling is a bit strange. This is due to autoscale function as it tries to fit the signal into the viewport. We will change the current signal scales to fixed scale. We can add some offset to the signals also. Okay, now let's capture these signals so we can analyze them deeper. We can do this with Typhoon Capture function. Normally, in capture mode, we should set the signal assignment again, but instead we will use the import from scope function, which will import all signal settings from scope. Signal assignment can be changed in capture too. Let's say we want to post-analyze the signals, but we need at least 2 million samples for that. We will use force trigger as we don't want to wait for any event. Okay, now we have 2 million points captured and we can zoom deep into the signals. We noticed some strange behavior in our circuit. We should inspect it closer. To do that, we will use the zoom tool. If we need to document the scene glitch, simply click on the save icon and save it as a picture file. Or if we want to post-analyze it further with MATLAB, for example, we can choose to save all the captured signals into MAT file. At the end, the whole session settings, including source, capture, scope settings, even contactor states can be saved, so later we could reload them and continue our work. Thanks for watching.